Hey calculates! So today we're doing section 1.5 and I had alluded that we would talk about the components to the rational polynomial graphs later in the chapter. So I've listed here the components that you look for in a graph. Of course, some other important features always to look for would be the x and or y intercepts, and you should know how to find both an x and a y intercept easily to help. And then you can plot those on your graph very easily. But to find the vertical asymptote, I'll look for the discontinuities. In other words, I'll look at what makes the denominator equal 0. And then for the horizontal asymptotes, I have to compare the degrees of the numerator and denominator. And if the numerator is bigger, there's no horizontal. You might remember that if the numerator is bigger by just 1, okay, seriously? Or actually I should say if the degree of the numerator equals the denominator plus 1, so it's greater by 1, then you get a slant asymptote. And if the numerator is less than the denominator, then I get y equals 0. That's the one I usually like. And if they're equal, then it's the leading coefficient of the numerator over the leading coefficient of the denominator. So when I look at this, first thing I'm going to spot is the vertical asymptote, and I can tell by looking at the denominator is x equals 2, and so I'm going to plot that right away. And then I'm going to pay attention for the purpose of finding the horizontal asymptote to the degrees of the numerator and the denominator. So the degree of the numerator is 0 because I have no x, and the degree of the denominator is 1. So numerator is less, which means I have a horizontal asymptote at y equals 0. And to find my x-intercept, I'll allow y to be 0, which means that fraction would have to be 0. So there's no x-intercept. Remember, I'm pretending that this is y. And if I plug in 0 for y and solve, it says 3 equals 0, which is preposterous. And if I find the y-intercept, it'll be 0 and negative 3/2. So I could plot that down here somewhere. And then I'm actually ready to draw a graph. I usually have students make a little tiny mini table. I will call him mini table. And then we'll test a number to the right of the vertical and to the left of the vertical. So I would try x equals 3 for the right and x equals 1 for the left. If I plug in 3 for x, I'll have 1 in the denominator, so that'll make my y value be 3. And if I plug in 1 for x, I'll have negative 1 in the denominator, which makes my y value negative 3. And so then I know which section my curve is in. Remember, it's like sheep, and it's always trying to get close to those asymptote fences. So there's my graph. And now if I look at what happens as x approaches 2, well, remember, the left and the right values have to be the same. So as I approach 2 from the left, I would be following along here, getting closer and closer. Oh, that's going to negative infinity. And as I follow back closer and closer to 2 from the right, oh, that's going up, so that would be positive infinity. So this is going to be a does not exist because they are definitely not equal. So one thing to note is an infinite limit is one that does not exist. Even though your answer is either plus or minus infinity, it doesn't mean that the limit exists. It just tells you what the y values are getting closer to. Instead, it still is a does not exist. And as a reminder, my vertical asymptote is a discontinuity at that location, whatever the no numbers were for the denominator. And vertical asymptotes happen when the denominator equals 0. All of that's just sort of a refresher stuff about things you already knew.